So hello everyone, welcome back to our channel, and we have started with the network analysis course and we have completed around 5 to 6 videos. So those who have not seen those videos, my humble request to you all is please see those videos and then watch this video. Okay, we have covered all the concepts related to source transformation, source shifting, basic concepts of network analysis, how the network should be given and how we should be simplifying those networks. All of them I've told you in my previous sessions. So please watch those videos, like this video, share this playlist to a huge number, and we are going to continue with whatever we have left in the previous video. That is, we have discussed star delta transformation derivation and how to convert star network into delta network and delta network into star network. Okay, so for that let's see with one simple example sum. After that we are going to solve many sums. This is one simple sum. Okay, that is, in the question they have given, find the equivalent star network. So here you know that this is delta network only because this is connected in this pi shape. I know that I told you, right? Delta network can also be called as pi network. Okay, we can also write it in delta network like this. See, this is 3 ohm and this 9 ohm and 6 ohm. If we make this meet of this common point here, so these two would be meeting here. So that's why this can also be written as a delta network. Okay, so now how to convert this delta network into a star network? We should be finding the equivalent star network for this, right? Okay, so here this is the delta network. Here the values of the impedances values, they have given it as 9 ohm, 3 ohm, 6 ohm. Consider any of the values, that is RA, RB, RC, because this is a delta network. And inside to draw one imaginary, like this you draw in pencil if you want, that is, and name it as R1, R2, R3, like this. Okay, so now we need to find the values of the equivalent star network. So we have seen the conversion of delta to star derivation. In that, in the conversion of delta to star, we have seen that the values of Z1, Z2 and Z3. In this we are having the values of R1, R2, R3. So how to find the values here? I have told you, in order to find the value of R1, we should be considering the opposite impedances, right? That is, opposite impedances, that is the product of opposite impedances divided by the total sum of all the impedances. Okay, in order to convert from delta to star, that is, R1 is equal to 9 ohm into 3 ohm divided by 9 plus 3 plus 6. Okay, in case of R1. So this is the formula, I have represented it. Okay, if you know the trick, directly you can do it. You don't need to write these intermediate steps. Okay, this would be taking time. I wrote it because for you people to understand it. Then if I go on solving, when I go on solve the problems, then these steps and all I won't be writing it. Okay, directly I am going to say you. I've already told you how it is. That is, this R1, we should be checking the opposite resistances or impedances. We should be doing the product of them, that is, we should be multiplying them divided by total. Similarly for R2, these two are opposite impedances, that is 3 into 6 divided by 9 plus 3 plus 6. Similarly for R3, 9 into 6, these two, this is in a straight line, so you should be considering these two. 9 into 6 divided by 9 plus 3 plus 6. Similarly, find the values of R1, R2 and R3. Okay, see, I have written it here. Whatever I have told you, I have written it here. Solve it. And when we solve for R1, we would be getting 9 into 3 divided by 9 plus 3 plus 6. That is equal to 9 3s are 27. By 9 plus 6, 15 plus 3 is 18. 27 by 18, if you solve it, you would be getting 1.5 ohm. Similarly, solve for R2, that is 3 into 6 divided by 9 plus 3 plus 6. So 3 6 are 18 divided by, this is again 18 for all of them. Keep it 18 constant. 18 by 18 is 1. Similarly for R3, 9 into 6 divided by 18, that is 54 by 18, that is equal to 3 ohm. So like this we have got the values of R1, R2, R3. At the end we should be drawing the equivalent star connection, and whatever resistances we have named here, that is, this is R1, this is R2, we have named it, and this is R3. Write the values of those resistances after calculation, then finally write the equivalent star network. Okay, hope you understood this problem. Okay, so now some complex problems we are going to solve, which is very interesting, and I guarantee you that you would be understanding those problems. Okay, so let's get to those questions now. So this is the simple problem here, the first problem of star delta transformation. So like this we are going to solve many problems related to the star delta. Okay, and I guarantee you that you would be understanding this concept very well if you follow all of my whatever problems I provide you if you listen to it very carefully. So this is the first question here, that is find the equivalent resistance between the points A and B. Okay, these are the 2 points here, the terminals here, they have given A and B for the network shown. Again, this is one complex network, but this consists of both star connection as well as delta connection if you observe carefully. Okay, and they have given the respective values of the impedances or the resistances. Okay, again the same thing which you have done for source transformation and shifting, analyze the circuit and we should be trying to reduce, that is we should be finding one single resistance between the terminals A and B. Totally how much we have here? 1, 2, 3, 4, 5, 6 resistances. We should be converting, we should be doing some of the you should be applying the concept of resistors in series and parallel, which I already told in the basics. That only we should be apply using star delta transformation. Okay, so now if you analyze the circuit very carefully, how can we reduce this is, we have here 2 terminals here. Okay, and this is not one terminal, that is here the branches are connected, but this is not one terminal. Okay, from this we don't have one separate branch going. Okay, that you should be keeping in mind. That I would be telling you in the later steps of this problem. Okay, first thing is analyze the circuit. We have one delta connection here, triangle, and also inside we have one star connection. What we will do is, in order to reduce this, we can convert this internal star connection into the delta connection. After the conversion of star to delta, how we would be getting is, already we have one delta outside. Okay, then inside also you would be having one more delta. Okay, like this with the resistances. Like this you would be getting, right? After the simplification of inside the star we have, right? That if we convert to delta, already one delta is there outside. Inside also one more delta would be coming like this. And here we can see that the 2 of the resistances like this are in parallel. We can convert it to one single equivalent resistance, and again we would be getting one single delta network like this. Okay, this is a rough figure in order to make you understand. Right, when you do resistors in parallel, then till here now let's do, then after that let's see how to simplify further. Okay, so now first step is internal star connection, convert it to delta. Okay, so how to convert star to delta, I have already told you, that is consider this 4 ohm resistance here. In order to convert star to delta, you should be checking for opposite resistances. That is here in this case all of the opposite resistances are 4 only. So in order to calculate the internal star, first write the delta connection. Outside delta connection you keep it as it is first. Okay, this is 4 ohm, 4 ohm, 4 ohm. So now we know that after converting star to delta, like this the circuit would be looking. Right, the circuit would be something like this. Right, I've already explained you. We just need to find the values of these internals. That is, this is 4 ohm now. I told you in the derivation how to find it. That is, first consider the opposite resistances. That is, we should be adding this, that is 4 plus 4 plus 4 into 4 divided by 4. Okay, so 4 plus 4 plus 4 into 4 divided by 4. That is equal to 4 plus 4 is 8 plus 16 by 4. 4 ones are 4 fours are. So you would be getting 12 ohm. Right. So that 12 ohm we should be writing where now? You should be writing it here. Okay. Because you have considered these two. Now, if you want to find the value of this resistance, that is, this comes between these two, right? Here it comes here. So now we know that when the resistance is here, the opposite resistances are these two, 4 and 4. So we should be doing again 4 plus 4. In this case, all the internal resistors are 4 only. So all of them we would be getting 4 plus 4 into 4 divided by 4. Again the answer is same, that is 12. So this also is 12. Similarly here also you would be getting 12 only. Okay, these 3 resistance values are also are 12. Okay. So now for these 3 we should be doing now parallel. That is, we should be doing 4 into 12 divided by 4 plus 12. Okay, for all these 3, since these 3 are also having the same values, so I'm going to do it only once. 12 4s are 48 divided by 12 plus 4 16. 16 1s are 16 3s are 48. So our intermediate resistance is equivalent resistance is 3 ohm. So our now reduced circuit is now 3 ohm, 3 ohm, 3 ohm, and don't forget to write the terminals A and B. So now like this we have reduced this part till here, right? Hope this is clear. Now after that, so here if those who have not understood, I'll explain you again. So this is star connection, right? So in order to convert this into intermediate delta, here we should be having one resistance. Okay, to find this resistance value, we should be considering the opposite resistances, that is these two. That is 4 plus these two opposite resistance or multiplication divided by the remaining resistance 4. Similarly, in order to calculate this resistance, we should be considering the opposite resistances, that is 4 plus 4 into 4 divided by 4. Okay, so that we would be getting our answer here. Similarly, for this resistance here, consider the opposite resistances, 4 plus 4 into 4 divided by 4. That is again we would be getting 12. In this case the value is same, right? So that's why I have written 12 12 12 all the sides. This is clear. Then after that we have parallel connections here, 3 parallel connections. Again the values are same here, 4 12 4 12 4 12. So that's why I have done only once here. Then we would be getting 3 ohm. So reduce it and write it like this. But our goal is we should be having only one resistance between these two terminals A and B. But we have here 3. Okay. So here we can see that these are the two branches where these two are going, and here they are meeting, but this from this point is not one terminal here. So how we can write here is just write it like this, A, B, and these two are there, right? Since this is not having one terminal, we can say that these two are in series, right? So we can write it like this. This is 3 ohm, these two are in series, so 3 ohm and 3 ohm. So we know that in order to reduce the series connection, we should be adding them. So you would be left with 3 ohm and 3 plus 3 is 6 ohm. So now our final connection is there. These two are in parallel. So we should be doing 3 into 6 divided by 3 plus 6. That is 3 6 are 18. 3 plus 6 is 9. 1s are 9. 2s are. So our final answer is between the terminals A and B, we are reduced with only one single resistance, and the value of that resistance is 2 ohm. Okay. So this is the simple problem. I've tried to explain it and I solve it. Okay. This problem hardly you should be taking around 5 minutes to solve this, because these are very simple problems. Okay. And marks grabbing problems, very easy problems. If you understand the concept of series parallel connections and star delta connections very well, you can easily solve it. But the thing is that you should be knowing how to do the first step only. If you go wrong in the first step, the whole problem is wrong and you will be getting 0 marks. Okay, the subject is only that we should be knowing how to do the first step. The starting step is very important here. If you understood that, and you can crack easily this whole subject only. Okay, so this is one problem. Let's solve one more problem now. So this is the problem again. Again the same question. We have the terminals A and B. We should be reducing this whole circuit, and we should be having at the end only one resistance between the terminals A and B. So this is again a bit more complex circuit, but similar to that we have solved in the first problem, right? Similar to that only. Okay, not much change is there here. Very easy, but we have one additional step in this here. Okay. So here in the last problem what they had is, here directly they had given the internal star connection here. But here what they have done is, external we have one delta connection, inside we have one star, and inside that star where the point meets we have one more delta connection. That is one external step, extra step here. Okay, what to do is, this is very simple. First consider this internal delta connection here. Okay, convert this delta to star. Like this I have written it in dotted lines here. Okay. After we convert this delta to star, we would be having 3 resistances here, right? After the conversion of delta to star, then we know that after that we can say that from this point to this point we are having 2 resistances in series. We can add them and make it to single resistance. Similarly here we would be having 2, and here also we would be having 2 resistances. okay, in series. So we can convert it to one single resistance, and at the end again we would be left with one star. After that we would be left with, sorry, one delta. After that we would be left with one star, similar to that of the previous problem. Then after that again the same procedure which I have solved already in the first problem. Apply the same procedure, that is, this is star. This star connection converted to delta, so that you would be getting like this connection here. Okay. So these three branches here would be in parallel, converted to a single delta connection again by finding the equivalent resistance. Then finally, between the terminals A and B, they would be mentioning here, these two would be in series. So add these two resistances and do the final parallel connection. Okay. So this is where I have just summarized this whole problem. So now let's solve this. Okay. Whatever we have summarized, let's solve it. So see, I have written this reduced circuit here, whatever I have explained here. And the external delta values I've kept it as it is, 8 ohm, and these three resistance values I've kept it as it is, because in that first step we don't have any, we should not touch this. Only this part is getting changed now, that is, this delta is converted into the star here. Okay, so now how to find the conversion of delta to star, I have already told you. In order to find this resistance here, consider the opposite resistances. This is 4 ohm and 4 ohm, but in case of conversion of delta to star, the formula is different. That is, we should be doing the multiplication, the product of opposite resistances divided by the sum of total resistances. Okay, that is 4 into 4 divided by 4 plus 4 plus 4. Right, for conversion of delta to star, I have already told you. That is 4 4s are 16, 4 plus 4 plus 4 is 12. So you would be getting our answer as 4 by 3. Okay, 4 by 3, right? So in place of here, we should be writing our value now as 4 by 3 ohm. Similarly, since in order to find this also, the same thing again you should be doing opposite resistances, product of that 4 into 4 divided by sum of total, 4 plus 4 plus 4. That is equal to again 16 by 12, 4 by 3 again. Since all the values here are same here, so that's why all these resistances values would be 4 by 3 ohm only. Right. So now next step, what I have told you, these here, from here to here, this is in series, this is in series, and these two are in series, converted to one single resistance. Okay, that is, you would be getting 6 plus 4 by 3, do it, that is 6 3s are 18 plus 4 by 3, that is equal to 22 by 3 ohm. Okay, so here we would be having on 22 by 3 resistances here. Okay, that you write it here. So external, all the connections don't go to touch it. So internally we would be having 22 by 3 ohms. Okay, this is 8 ohm. Now again, in the previous problem, how we have solved the same thing, convert this external star to delta. Okay, that is, we have here a star connection, we should be converting this to delta here, like this I have told you. That is, in order to convert star to delta, the formula is, in order to find here this resistance, you should be considering the opposite star resistances, that is 22 by 3 plus 22 by 3 plus 22 by 3 into 22 by 3 divided by 22 by 3, right? So what we would be getting here, so if you bring this 22 by 3 here, it would be 3 by 22, so that 22 22 3 would be getting cancelled. We would be left with these three terms here. Okay, so here we have one common denominator 9, so that would be 66 by 9, right? Sorry, 66 by 3, right? These three would be left, so that is equal to 22 only. Okay, we would be getting 22 ohms, right? Similarly, for all these three also would be 22 ohms only. So that's why I'll directly write the reduced circuit here. I know that I've scribbled it a little bit, but I hope that you would be understanding it. Okay, this is 8 ohm, 8 ohm, 8 ohm, and these are 22, 22 and 22. Again, these three are in parallel here. Do the internal parallel connection, that is 22 into 8 divided by 22 plus 8. 22 8s are 176, 22 plus 8 is 30, and if you want to reduce this, we can do this with two table, that is equal to 88 by 15 ohms. Okay, so that is our final connection what we would be getting. Don't try to forget to write the terminals here, A, B in all the steps. Okay, so you would be getting 88 by 15, 88 by 15, 88 by 15. So now between the terminals A and B, these two would be in series. I told you, right? So that's why we should be adding these two. We would be getting 88 plus 88 is 176 by 15. Okay. So here after the addition we would be getting 176 by 15. That is parallel to this resistance, right? 88 by 15. So we should be doing 176 by 15 into 88 by 15 divided by 176 by 15 plus 88 by 15. That is parallel connection. Okay. Solve this equation, put it in the calc. We would be getting our final answer as 3.99 ohms. Okay, or you can write it 4 ohms. No problem. Okay, solve this equation, put it in the calculator and solve this. Okay, I'm not going to solve it because it would be taking a lot of time. Our final answer would be getting 3.99 ohms something as our answer. You can convert, keep it as it is, or convert it and write it as 4 ohms. Okay, hope this problem is clear. I've tried to explain it. So that's all, guys. Thank you for listening this longer. In the next session, we are going to solve few more problems related to star delta transformation. Like this video, guys, support us, share our playlists, and all the best to all the backlog students. I hope all of them would be passed. Okay, thank you.